Okay, let's dive in. We have a really fascinating piece of tech in front of us today, the Thor Broadcast F-DVI-TXRX extender.
Right.
And our mission, really, is to unpack why a device like this even exists. I mean, why build one box to bridge ancient video standards like VGA with modern fiber optic networks?
Well, what's so interesting is that it's essentially the ultimate compatibility machine.
Oh,
It's not just an extender. It's a whole solution built on standard IP tech for, high-end AV broadcasting and KVM control. It solves this huge logistical nightmare of mixing old and new signals over just massive distances.
so let's walk through the basics. How does it work? You have the transmitter, the TX unit,
Yeah.
that plugs into your source, say a PC, and its job is to take the video, the audio, the USB, and just convert it all into IP packets.
Exactly. It digitizes everything. Then those packets travel over a standard gigabit Ethernet switch.
And on the other end, the receiver, the RX, it just grabs those packets and turns them back into usable signals for your monitor, your keyboard, or so on.
Converts them right back out. HDMI, DVI, VGA.
Yeah.
All of it.
I think that signal flexibility is the most critical insight here. It's not just about HDMI for the future. It's about being compatible with DVI and even old school VGA.
Yeah, through the DVI connectors.
For a system manager, that must be the real takeaway. You'd rather buy this one sophisticated bridge than spend, 100 times more ripping out a whole control room.
That's the crux of it. This is strategic cost management. And when you make that choice, you need serious range.
Which is where the optical fiber comes in.
Precisely. It uses SFP modules, and the distances here, I mean, they completely change how you can design a system. You're looking at up to 3 kilometers on single-mode fiber.
3 kilometers.
Or, 550 meters on multi-mode. That is absolutely mission-critical range.
And having that solid IP transport gives you options for how you send the signal, right? It can do a simple one-to-one unicast, which is like a direct line, but also one-to-many multicast and even many-to-many.
And just to clarify that for you, multicast is so important for video. It sends the signal just once, and only the devices that are supposed to get it will listen.
But there's a catch.
There is.
Right.
For that to work without flooding your whole network, your Ethernet switch absolutely has to support IGMP, the Internet Group Management Protocol.
Okay, so once you've got this long-distance video pipeline, it becomes about more than just watching. It's about control.
And that's where KVM is just essential.
Keyboard, video, mouse.
Yep, for remote PC control. The transmitter has a USB-B port for the computer, and the receiver gives you multiple ports for the user 2 fast USB 2.0s and 2 for older devices.
So a technician could be sitting almost 2 miles away, but it's like they're right in front of the machine.
That's the idea.
And the feature that really elevates this whole thing is the video wall scaler.
Oh, absolutely. It has a built-in engine that lets you take a bunch of these receivers and configure them into one giant, seamless display.
And it's not just tiling them together.
No, it's more complex than that. The internal scaler lets you manipulate the image, including, and this is critical, rotation.
Like for portrait displays.
Exactly, 180 or 270 degrees. It's essential for professional digital signage. And the resolution is a really clean 1080p or 1920 by 1200 at 60 hertz.
So with all this digitizing and sending signals back and forth, you have to wonder, is there a noticeable lag, a trade-off?
That's a great question, but the design really accounts for it. It's a pure hardware solution.
Plug and play.
Right. No software to install that might introduce lag from the OS. And the fact that it's FCC, CE, and RoHS compliant, that isn't just a regulatory checkbox.
In a hospital or military setting, that's proof.
It proves it's reliable, it won't interfere with other sensitive gear, and it won't fail when you need it most.
So what we have here is a device that bridges legacy video with modern fiber, gives you full KVM control, and powers these massive video walls, all across critical infrastructure.
If you connect all those dots, its real value is just letting old, reliable technology keep working safely inside these huge new IP environments.
So the existence of a device like this, one that can take an analog VGA signal and push it reliably across a 3-kilometer fiber optic cable, it raises a really interesting question for you to think about. How many mission-critical systems, maybe in courtrooms or military operations, are still fundamentally running on video standards from the 1990s, demanding this level of complex integration just to stay connected to the modern world, something to mull over until our next deep dive?